But you can get the mic to comment on the graph. Non, je suis désolé, putain, les gars. Putain, mais comment ça? Je veux rien. Ma VM bouge pas. T'as rien?
Ta VM bouge pas, et t'as pas de, tu peux pas, sous Windows, pas de, sous Linux, t'as pas d'USB?
Tu vois après, il marche pas, c'est super bizarre, c'est un truc de...
We're having few issues connecting, myself connecting and Thomas booting his Windows VM, so give us 5 minutes, please. So, because we don't have any material to present or to display. We could start, but...
Ouais. Attends. Comment je peux faire? Est-ce que je peux demander à quelqu'un de mettre toutes les slides sur le boot? C'est bon? Ça a démarré? D'accord. Non, parce que sinon je demande à quelqu'un de me charger toutes les slides. J'étais là à 8h30 quoi, pour éviter ça. Je te jure. Pas un câble physique.
j'utilise mon compte. Thank you for your patience. So this is the Bess working group, and we've already consumed 10 minutes or no 6 minutes. So shit happens.
So sorry. The note well, you know it already. We won't spend time on it, but be aware that you need to follow these rules. We have had some imperfect episodes in the past. We need a note taker. Who's willing to take notes? Should we pick somebody?
Thank you.
Thank you, Sue. So please fill in the blue sheets. I know where they are now, and then return them to the chair at the end of the meeting. So since last IETF, we transitioned from L2VPN, S3VPN to Bess. So most of this is now done. We have a few documents which have not yet been renamed, but that's cosmetic. We had 2 documents published, actually, well, one in Bess, the MVPN, MLDP, and LRI draft. And the VPN specs were not technically in Bess, but were closely related to Bess, and they were finalized in the past months. We have 4 documents which are now in ISG review or further down the process. We have also 4 documents which have gone through working group last call and who are waiting for Shepherd write-ups. So stuff to do for the next month. And since last IETF, we adopted 11 drafts. So it's a lot of documents. Some of them were waiting for adoption calls for some time. Some of them were more recent. But it means that we have a significant amount of work to achieve in the months to come to progress these documents. We also had 1 document which was the call for adoption but not adopted. Go ahead, Ali.
So with respect to the 1 document that didn't get adopted, some people missed the working group call and didn't respond to it, including myself and some of the co-authors. So because there were so many things going on at that time. So we'd like to ask for the reinitiation of the working group call.
Yes, we as chairs, we need to see an interest in the proposal, also hearing more from people who actually need this implemented.
Sure. Since the call, there has been a lot of discussion and topics, but some people prefer to have the discussion offline. So I've had a lot of discussion offline on this topic.
So it's good to encourage people to have the discussions on the mailing list.
Yeah.
It helps a lot for, everyone to be involved in the proposal.
Okay.
And to have an idea of the amount of support behind the proposal. Actually, that's something that's true for most documents. We have a continuous issue with many documents who are barely discussed on the mailing list. That's not specific to this document.
Right.
So it's important
just when
as a general message to encourage the discussion on list on the different drafts, including draft that are working group documents.
When the sender doesn't include the mailing list, I typically don't, I go along with that, and because I'm assuming, he preferred not to publicly discuss it or whatever, for whatever reason. But maybe for the benefit of the working group, I think it's better to have these discussions
I think what you could at least do, Ali, is to summarize the comments you've received and share them on the list.
Okay, that sounds good.
So here are a few other documents that are active in the document list. So if people want to comment on these documents, typically authors, to give an idea of the progress on the document, they're welcome to do it now. But since we are late, we'll likely move forward. The topic of young data models is a topic that's a subject of a lot of work these days. So we are including this slide from the routing area young coordination group as a reminder for people working on young models for Bess. Keep in mind what is explained on these slides, what is required to ensure proper coordination between all the young related works. So the agenda for today is the following. If you have comments on the agenda, please do them now. And if no one has any, then we'll start with Kyo. Kyo?
You need to stay here.
That's for the camera.
If you need to move, move, but otherwise you won't be on the camera.
Okay, camera. Okay.
You can take it now. Oh, sorry.
The first is reproduction.
Feed reduction or off?
Reproduction first. Good morning, everyone. I'm Xiaohu from Huawei. The first presentation is about reproduction in the virtual subnet contest. Virtual subnet is airsweeping-based subnet extension solution which can be used to build layer 3 overlays within or across data centers. Since a subnet would be extended across multiple P routers, host routes would be exchanged across P routers. In this way, the resulting fib size of P routers may become a scaling issue, especially in large-scale data center environments. The fib reduction draft introduced a method to reduce the fib size of P routers in the virtual subnet contest. This draft described a simple method for further reducing the RIP size of P routers, which is useful in the case where P routers don't need to maintain any remote host route on the control plane. That to say, remote customer host route will be learned on demand from the route reflector, while remote subnet route could be learned as normal. Next slide, please. P routers as RR clients would advertise local host routes to the route reflector. Meanwhile, P routers notify the RR not to send remote host route by using the airsweeping prefix ORF. That to say, P routers only request subnet airsweeping route. The RR is configured with non-route for more specific subnets, which is corresponding to the extended subnet. This non-route would be distributed to BGP. In the case where R is not available, to transfer layer sweeping traffic, any P router with a full routing table could do that work on behalf of the RR. On receiving a packet destined for a remote C host, ingress P router would forward that packet to the RR, which in turn forward the packet to the egress PE. Next, please. To avoid any potential path strength penalty, P router could perform on-demand host route learning by using the air sweeping prefix ORF upon receiving either an up message from a local C host without any matching C host route for the target host, or an IP packet matching one of the most specific subnet routes learned from the RR. Remote C host routes would expire if they are not used for packet forwarding for a certain time. Once the expiration time is approaching, P routers would notify the RR to remove the corresponding layer sweeping prefix ORF entries. In the spine leaf node topology, there is no need to enable on-demand host route learning, since those packets destined for remote C host would have to traverse one of those spine nodes. In this case, P routers just need to learn remote subnet route rather than remote C host route from the RR. Okay, just another presentation. The next will describe the layer sweeping ORF. Next slide. The address prefix ORF as defined in RFC 5292 is used to perform address prefix-based route filtering. However, this ORF is not much suitable for a layer sweeping case, since there are no route target field contained in that ORF entry. This document built on the above RFC and defines a new ORF type, which is called layer sweeping address prefix ORF. That can be used to perform layer sweeping address prefix-based route filtering. The layer sweeping prefix ORF can support prefix length or range-based matching, wildcard-based address prefix matching, as well as exact address prefix matching for layer sweeping address families. The layer sweeping address prefix ORF is applicable to reduce RIP size P routers in the virtual subnet context. You can see from this figure, the only addition to the address prefix ORF is a route target field. In addition, the prefix field doesn't include the RT part of a layer sweeping address prefix. For example, in case of IPv4 address family, only the IPv4 address prefix part of the IPv4 address prefix is contained in the prefix field. When performing a route filtering for layer sweeping prefix, route target should be matched. In addition, the address prefix ORF specific matching rows as defined in RFC 5292 are all preserved, except that the RD would not be compared. Next slide, please. That's all. Any comments?
Okay, thank you. Next speaker is let me check. Is Robert.
Hi, I'm Robert Kepler from Jupiter. I'll be talking about multicast MVPN fast failover. Okay, so this has been presented before, so I'll just give an overview of the hot route standby procedures. So with hot route standby, the downstream PE sends its C multicast route to its primary upstream PE as normal, and in addition, it sends a standby C multicast route to its secondary upstream PE. With hot route standby, this will cause the secondary upstream PE to treat this just like a normal C multicast route. It will join back to the source, draw traffic to it, send traffic into the core on the provider tunnel. So traffic will flow to the downstream PE in a live manner, and the downstream PE will select traffic from one of its provider tunnels, send that traffic to its receiving downstream CEs. Upon a failure, the downstream PE can detect a provider tunnel failure and then switch over traffic from, forwarding from what would normally be the primary provider tunnel to the backup provider tunnel. There are different procedures mentioned in the draft on how to detect a provider tunnel down. So that's just an overview. So since the last revision, we added an additional method of determining the provider tunnel status. This is a method to signal the BFD discriminator in the MVPN IPMSI and SPMSI AD routes. Then it uses multi-point BFD to determine the provider tunnel status. These procedures were described in a previous draft, so we've merge the text from that draft into this draft, so merge the drafts. The author list has been updated as a result. The number of contributors has grown quite large, so the author list has just been updated to the editors, and the other authors were moved to other contributors. So that's it in the latest rev. So we would like to hear of any comments, suggestions, reviews, and we would like to ask for adoption by the working group. We feel the draft is in good enough state to be adopted. There's interest in the draft. It's already implemented, it's deployed, so there is interest in this work, we feel. So we would like to move forward with adoption if possible. Any comments?
Noble Akia from Big Switch. Just a minor comment that BGP BFD attributes describes BFD discriminator as 2 octets, but it really should be 4 octets.
Okay, thank you.
So we were effectively waiting for the merge with the draft you mentioned. Would like to have a feeling from the room on who thinks the draft is ready to be adopted as a working group document. Thanks. Je le poserai sur la liste parce que je pense que c'est...
Next speaker is Eric, please.
camera, you stay in the square.
In the
on
square.
Yeah. But if you don't, you move.
Okay, as many of you know, an MPPN explicit tracking is a set of procedures by which an ingress PE can figure out who the egress PEs are for each individual flow or for certain sets of flows. We wanted, as part of the yes? Well, I think I am.
As I say, keep the mic. Take it in your hands.
Is this any better?
Yeah.
Okay. As part of the beer work, we wanted to enhance the extended tracking procedures. I'll talk about it in the presentation this afternoon. At the same time as we're thinking about this, Andrew and Jayon wrote a draft pointing out that apart from any enhancements, there were already mistakes in the specifications of the explicit tracking procedures, especially as to relate to the wildcards. So what we've done is combine that draft with the draft on the explicit tracking extensions for beer to have one draft that addresses kind of open and explicit tracking issues. And some of the issues that were raised is that when we did the original MPPN specs didn't have any notion of wildcard fields in the SPMZ-AD routes. When we added wildcards, we didn't really go back to the explicit tracking procedures and make sure they still work the way they were expected in the presence of wildcards. And there were also some of the more minor errors that need to be fixed. Next slide, please. The way the explicit tracking mechanism works is that when an SPMZ-AD route is sent, the SPMZ-AD route always identifies a particular flow, or in the case of wildcards, is a set of flows that carries a PIMP tunnel attribute, which usually, but not always, identifies a tunnel. And there's a flags field in that attribute, and one of the bits in that flags field is the leaf info required bit, or the L bit. And the ingress sets that, and the egress is supposed to respond back with a leaf AD route and the leaf AD route contains the NLRI from the SPMZ-AD route. So if the NLRI identifies a particular S, G flow, then the leaf route that goes back says, oh, I need this S, G flow. The use of this bit is mandatory for certain kinds of tunnel types and optional for others. And there's even an option to send an SPMZ-AD route with a PIMP tunnel attribute that does not specify tunnel at all, but has the L bit set, just in order to get the tracking information without also binding to a tunnel at the same time. Next slide, please. Now, before we introduce the wildcards, figuring out if an ingress PE knew it had to receive a particular S, G flow and wanted to figure out what tunnel to receive it on, was a fairly straightforward process. It looked at all the SPMZ-AD routes. It got and figured out that one of those encode S, G in the NLRI, and if so, that's the match. We call that the match for reception. With wildcards, there can be more than one such match. You can have a more specific match or a less specific match, but you can also match the wildcards. And one of the things that needs to be fixed is we need to make it clear that the match for reception is not simply the most specific match, but it's the most specific match that actually specifies a tunnel. You probably wouldn't get that wrong if you're implementing it, but if you did apply to what the spec says, you would do it wrong. Next slide, please. In combining wildcards with explicit tracking, we really need to introduce a new concept. The wildcard RSC does introduce this notion of match for reception. It tells you how to find the tunnel on which you can expect to receive the flow. In this draft, we introduced the notion of a match for tracking, and that finds the SPMZ-AD route whose L bit being set or not set tells you whether you need to respond with a leave AD route. A couple of quick examples, right? If you have a double wildcard SPMZ that specifies a tunnel, and then you have an S1, G1 SPMZ that doesn't specify a tunnel but does set the L bit, and you have no S2, G2 SPMZ at all, then both of the flows mentioned, S1G1 and S2G2, will be a match for reception with the wildcard SPMZ, and they'll travel on that tunnel. But only S1G1 will actually cause the leaf AD routes to be generated. But it's the only one that has a match for tracking with the L-bit set. And some of the interesting properties of this is that a more specific match for reception may actually block tracking. For instance, if the double wildcard route specifies the L-bit, and there's a separate S1, G1 SPMZ that specifies the tunnel but doesn't set the L-bit, then S1 G1 won't get cracked, right? Because the most specific match does not have the L-bit set, but does specify a tunnel. In this configuration, you would actually get tracking of the star, star, but you wouldn't know. You would find out which egress PEs need to receive data on the star, star tunnel, but you wouldn't know which flows they're receiving. Next slide. There's also some issues on handling explicit tracking, especially in PIMC-AD routes that don't specify any tunnel info, how to handle that at the autonomous system border routers. But I've left that out to save time, but it's in the draft. Next slide, please. The biggest change is the explicit tracking for beer, right? Because in beer, every packet, the nature of beer is every packet carries the list of egress nodes that it needs to go to with a coding that has one bit per node. So to incorporate this into MVPN, we need a way to specify that beer is being used. And what the beer MVPN draft now requires is you send a double wildcard SPMZ. The PIMC tunnel attributes specifies beer as the tunnel type, which really means that beer is being used. But it's not enough just for the ingress to say I'm going to use beer. In order to use beer, the ingress has to know who all the egress nodes are for each individual flow. So what the draft now says is send a double wildcard PIMC, and then for each individual flow that you're sourcing, send another SPIMC that's whose PIMC tunnel attributes sets the L-bit, but doesn't actually specify a tunnel. And one might ask, well, isn't this too much signaling? I mean, once you send a wildcard SPMZ, you say you're using beer, what is the point actually of sending all these SPMZ AD routes? So next slide, please. So we propose to optimize the procedure in the case in which you really need explicit tracking. You don't need to specify, in which you specify the tunnel, in the star-star route only, and you need explicit tracking on a per flow basis, and you don't want to have to send SPMZ AD routes for every flow. So we propose to define a new flag in the PIMC tunnel attributes flag field, which we call the leaf info required per flow. This would be set in the PIMC tunnel attribute of the double wildcard SPMZ that says we're using beer. And when the egress nodes see that, they would immediately respond with a leaf AD routes that specify not that they're joining, the star tunnel, but that would specify the individual SGs that they're joining. So this is like one SPMC AD route can elicit a whole bunch of leaf AD routes. And what you save is all those extra SPMZ AD routes that really have no function. To do this, we've made a little modification to the rules for constructing the leaf AD routes so that you can tell when you get one that it was triggered by this procedure and that you don't have to look for an exactly matching SPMZ AD route, that they really match the double wildcard route. So another slide.
You don't have any more.
Is there any questions or comments on this? Too esoteric or too arcane? Too boring?
Eric, since you didn't mention it, do you think the document is ready for adoption or not?
Do you think the document is ready for adoption? Okay, the reason I'm thinking about what's the quality of the document, I think the document is sufficient quality to be adopted, which means it serves as a basis for future work. I haven't really heard an alternative. The fixes I mean, I think the fix is right. I can imagine that people will want to discuss the new optimized procedure. But having said that, I guess yes, I think it's ready to work in group adoption.
Okay. Andrew?
Hey, Eric, maybe we can take. I think we talked about a few things. We probably may need to put one more version before that. Doesn't necessarily need to wait till the next IETF. I don't think it's pretty solid in my. But there is like one or two smaller issues that probably we should.
Yeah. Okay.
We should
we can
clean
fix
up
those.
before.
Doesn't really matter
Yeah.
whether they fix before or after,
Yeah.
as long as we've.
Yeah.
We'll fix them. The first time I mentioned first time I wrote this, I went to such great pains to write down the definitions very precisely, and I made a number of mistakes, right, which was Andrew going to a bit of a, what is he trying to do? But so I guess there's still some mistakes.
So I just have kind of one comment for those in this room that have they have implementation of explicit tracking, to actually go and look what your code is doing, because from our experience we found that there is not everybody behaving as the specs are what I intended to, or it's captured here. So have a look.
Might be interesting actually to hear on the list about some of the interoperability problems that actually show up. Anything else? I didn't go over time.
Robert? Yeah.
Okay, I'll be talking about some new UMH selection procedures using source active routes. So currently, RFC 6513 gives some different options on doing UMH selection procedures. These are based around the source address to select your UMH. However, under certain conditions, you may want to take more than just the source address into account. One example of this might be if an anycast address is being used to source the same content from two different head ends. Then a receiving PE may want to receive the content from head end 1 for group 1, but head end 2 for group 2. And if they're using the same source address, then this isn't really feasible today. So what is being proposed would be to use the type 5 source active routes to help drive the UMH selection procedures. So with this method, the ingress PEs will be set as an RP or MSDP peer. In the MVPN procedures, there are two main modes of operation, one of which is you set one of your PEs to be an RP or MSDP peer, and those PEs advertise the source active routes when they learn of the sources. So these procedures are building on top of that mode of operation. So the ingress PEs advertise the source active routes as normal, and then the egress PEs will be choosing the UMH based on the best source active route by its BGP route selection methods. The ingress PE can be configured with any policy, such as adding a BGP community to the source active routes to help drive the route selection procedures for the egress. But the egress will choose the best source active route, and the PE that advertise that source active route will be the UMH. So those are the procedures being proposed here. So this is just a picture showing what I described before of two head ends using the same source address. These ingress PEs are advertised in the type 5 routes, which are the source active routes. The egress PE receives these type 5 routes, and for a given source group can determine which source active route is the most preferred, and therefore which one is its UMH. So this is a work in progress. We plan on adding some additional procedures around what if, instead of using the same anycast source address from head ends, you use different source addresses, and how the procedures would be at the egress PE to select one source, join back from one source and not another source. So basically treat these as the same flow. So we are interested in any feedback so far if people think these methods are interesting, and we're going to have a next rev of the draft for the next IETF. So any comments on this so far?
I have a question. Is the solution applicable only to ASM multicast?
Yes.
Okay. So one comment I would have is that the problem statement seems generic, like not specific to any source multicast. So have you thought about a solution that would be applicable as well to SSM multicast?
The procedures as they are not applicable to SSM, just because the way that the RP learns of the sources, advertises type 5, and that's used for the UMH procedures. We can, if you're saying that you'd like us to consider SSM and make it more general, then we can do that. But as it stands now, it's ASM only, and that's the use case that we're solving this for.
Okay, understood. Eric again, please.
Well, this draft is about a truly exciting technological innovation, right, which is how to set up the IANA registries for the PIMC tonal attribute flag. Do you recall I mentioned before that I wanted to use a new flag bit in the PIMC tonal attribute? So as any good citizen would, right, I think, well, this now requires an IANA registry, right, and we need to have a little draft to set up an IANA registry. And then I started to discover some issues. I wanted to, the IANA registry should have been set up, when RFC 6514 was adopted, but it wasn't. As I wanted to figure out what bit I wanted to use, I discovered that there are other drafts and even some deployments that have been grabbing bits for their own use. And in fact, I think 5 of the 7 available bits are actually claimed by either drafts or deployments. And without a registry to record these, right, you inevitably are going to end up with a code point clash in the field. And if you've ever lived through one of these inter-vendor code point clash things, it's extremely painful, because nobody ever thinks for the first 2 weeks that they're troubleshooting that maybe someone's using the code point wrong. And so a lot of time and effort are wasted. Next slide, please. This is just a picture of the fields in the PIMC tonal attribute, and as you can see, the architectural principles behind the construction of this are a little bit weak. The way the MPLS label is used and the way the tunnel identifier is used, that's different for different types of routes and different tunnel types. The L bit, though, is defined in a way which is independent of the tunnel type, but it's only used in a certain route type. So it's used in the IPIMZ and APIMZ and FPIMZ AD routes, but not in the leaf AD routes. So there's no, if you just look at it, it's not clear what the principles are as to what things it can be dependent on what other things. Next slide, please. So at first, it seemed like this was a really simple issue to avoid future code point clashes with the use of the flags in the flags field. We just need to ask IANA to create a registry called PIMC tonal attribute flags. And we could preserve all the existing uses, since there's still less than 8 uses, and there's 8 bits, and we could add the new flag, and maybe we'll have a bit or two left over for the future. And if we don't mind using up, so many bits so soon, this is a fairly easy thing to do. If you think that maybe, gee, we only have 8 bits and we've used them all up almost already, well, we have some decisions to make if we don't like that. Next slide. And the main decision is whether we want to have one registry for the flags field or many. As it is now, if you look at what's in the flags now, the L bit is defined for all the tunnel types, but only certain route types. As I just said, the new leaf info required for flow flag that I mentioned just before is similar in function to the L flag. We have the same scope of applicability. Most of the other new flags that I've heard about are from the EVPN effort, and they have some new type of tunnel, and some English replication, some new type of English replication tunnel that they use multiple bits for reasons I don't quite understand. The scope of application of those bits, I'm not really sure myself whether that's per SAFI per tunnel type, or per AFI SAFI per tunnel type, or per route type per tunnel type, I mean, it's never really been addressed as what the scope of applicability of those flags are. Anyway, so thinking this through, we have at least 3 different proposals for how to set up the registries. Next slide, please. The first proposal is just to have one registry. You kind of want to avoid using flags for things that are specific to particular tunnel types, because if you have just one registry, once the bit is assigned a meaning, it's assigned a meaning, and the bit wouldn't be reusable for other things. So it has a very small applicability. It really wastes a lot of the bit. So the explicit tracking flags would go in there. One might consider moving the EVPN flags somewhere else, since they have a small scope of applicability. Somewhere else could be another attribute, or an extended community, or you could figure out some way to encode them in the tunnel identifier field. There's many possibilities. So the advantage of a scheme like this is very simple, and it's easy for IANA to manage. And if you've written a lot of RFCs with IANA considerations, that IANA really does, and very reasonably, demand simple procedures. They like to be able to look at the registry description on their web page, right on the set of assigned values, policies, and figure out what value they can assign to the next request. They don't like it too much if, to figure out what value is available on this registry, you have to look at some other registry and see what values have been used there. Simple and free of dependencies. Next slide. Proposal 2 is one that a number of people have proposed to approve. This is mostly from the people who, in the EVPN world, who have been squatting on some of the bits without registering them. I think, well, what we should really have is a registry per tunnel type, right? And then you can have a set of 8 flags that are meaningful only for the IR tunnels, or the AR tunnels, and perhaps only as those are used in EVPN. And the advantage of this is that they don't have to preserve the implementation, or whatever deployments there are. They don't have to do anything. The disadvantage is now we've got to think just how many registries do we need, and is it per tunnel type, or per tunnel type per SAFI, or per tunnel type per AFI SAFI? We've got to work that out, and then for every new type, we use every type, and the tunnel type, and the route type, right? When every time you invent one of these new types, you have to remember, I better go look at that registry and see which of these flags are applicable to my type, and which are not applicable to my type, and what the procedures are. And that will probably lead to a lot of omissions and wrong guesses about what flags might be might be useful. You know, someone would say, oh, you don't need the L bit, you know, if you have an LDP tunnel, and someone else might say, no, it's still in-stream to do explicit tracking if you have LDP. You don't need it to set up the tunnel, and there's a lot of things that could go wrong. It's also possible that, of course, we'll need flags for multiple tunnel types, but we run out of bits for some of the types, right? And it's be hard to do with simple extensions in the future. Next slide. So proposal 3 is a split the difference proposal, right? This is, you know, we could say, well, the bits that are being squatted on now, you know, bits is 0, 3, 4, 5, and 6, number from the left, I think. We could have type registry, then we can have this universal registry that has only bits 1, 2, and 7 in, and 7 is the L bit, right? We use one of the other two for the LIRPF bit. And this is also something that we can do that doesn't require us to make a hard decision now. But I don't think this really flies. It's kind of hard for IANA to manage, you know, every time that you invent a new tunnel type or a new route type or a new SAFI, something you need to set up, you know, new registry for those types. It's really hard to ensure that you won't infringe on the universal bits when you do that, right? Because there's no place for that IANA can look and say, oh, when I set up this registry, I have to mark bits 1, 2, and 7 reserved, right? So it's going to be easy to make mistakes like that will lead to code point clashes. And this proposal also does run us out of bits now. And I know MVPN and EVM have been going around for a long time, but I think it's still kind of early in the life of them, and it's an uncomfortable feeling to think that we've used up all the flags already. So there are I think this is my last slide. There are. Yeah, one can imagine other possible proposals, but we wanted the chairs, I guess, wanted really to see what the sense of the working group is for which way we want to go here. And we need to make a decision very fairly. We don't want this to go on for years. We're going to have the registry. We need the decision fairly quickly so that we can do our extensions. Questions, comments?
Jorge Rabadán, Alcatel-Lucent. So as one of the authors of the optimized ingress application for the EVPN draft, my personal opinion is proposal 1 is we don't really like it because it implies that we need to move the flags to an additional attribute, and we see it as a unnecessary overhead at the moment, especially because we have bits available in the PTA. But I understand the complication of adding registries per SAFI per tunnel type. So I don't know. In my personal opinion, maybe the fair trade-off would be to have a registry per SAFI only. And if we do so, and we agree on that, we can change the draft to make sure that we change the use of the flags instead of per tunnel type to per SAFI type. But in any case, I think it would be good to take it to the list and see if people are working on some other solutions, making use of the flags and what people think about it.
I have one comment on proposal 1. If we just go to the so as you formulated it, you suggest one registry, but avoiding the use for flags specific to a certain tunnel types. The background, as I see it, is that we are not really looking at a space where we have a scarce resource. As you explained here, we have many options to place future flags. So I think we should strive to go for the simplest solution for IANA. So something like proposal 1, or maybe like like what you didn't name it proposal 0, but your first option is to say possibly do nothing or do the simplest thing. I think we should try to do this. Use the bits in the actual space and explain that for future flags they could be stored in an extended community or exploit space in tunnel types if it's a better solution, but even an extended community would be a simple solution and working solution.
Yeah, I think that's a very sensible comment that preserves what we've done now, preserves the bits that are squatted on without making people change them, gives us a few bits to expand, and we'll use them up soon, and we'll have to do something else.
So, Eric, while I don't want to make things complicated for IANA, and I don't have any very hard preference for one of the proposals, but I think the argument that it's hard for IANA to manage is a little bit, actually comes back to ourselves, because what is hard here is not the IANA management, it's the policy we need to write for helping IANA to manage the registries. So it actually comes back to ourselves, and if you write a clear and good policy, it's easier for IANA to manage.
Well, that part is true. I will disagree with a little bit of a nuance. As you may remember, I recently did a reconstruction of the extended communities registries, which, if you look at the extended communities specifications, yeah, it clearly says, that you can't assign this value in that registry if this other value was assigned in this, in this other registry. So while the policy is clear, it's really hard to apply it. Right. The IANA processes don't seem to deal with it, and even us poor engineers who write the specs have actually made incorrect requests to IANA based on the author's misunderstanding of the way the registries are structured. That's why I think simpler structure, the less likely we are to make mistakes.
Yeah, I think I would like to go with the simple solution for IANA. That's a good thing. What I'm saying is just that the problems are rather people writing IANA sections and working group reviewing them to actually, when we get things that are wrong into requests to IANA, that's why we cause problem.
So one more comment based on what you are saying, Jorge. I'm not really in favor of an approach with a registry per SAFI, given that some extensions that we are talking about, like your optimized ingress application draft, today are proposed for the EVPN SAFI, but could be useful tomorrow for the multicast VPN SAFI. So I think we should. This complication of having multiple registry doesn't win us much for the longer term. So I would not really like this approach.
Yeah, that's all right. But even in that case, you can register those bits again for the new SAFI, right? So
except if they have been taken for something else in between.
Yeah.
In which case you would end up with different bits used for the same purpose in different SAFI, which is messy.
Okay.
A follow-up point on that. Jeffrey Zhang from Juniper. So to the point of whether MVPN can use the same procedure for its replication. Actually, MVPN already has a virtual hub and spoke method that achieve the same thing.
So we will certainly pursue the discussion on the list to progress on this INR registry. A side point that the comments made this mic were without my chair hat, so all options are open for discussion, and as chairs, we are just listening to the working group.
One thing would be nice if you could all keep in mind and tell your developers, right, is when they see a bit tree and think of some great things to do with it, it needs to be registered, right? Don't just do it. And if there's no way to register it, then you can talk on a list about what the registration process is. Because these code point clashes that occur in the field after deployment are extremely painful.
Yes, this is very true. Thank you.
So we really welcome all the interested parties to effectively work on that topic, because we took the decision to adopt this immediately as a working group item because we believe it is important to be tackled. But that effectively means that everyone is welcome in reaching a solution.
Jorge, please.
So, good morning, everyone. My name is Jorge Rabadan, Catalucent. And I'm going to present two companion drafts about proxy ARP and enable discovery in AVPN networks. So the first one is an informational draft, and here you have the co-authors. It's basically a combined ALU and DKIX effort, and it's a work in progress. So we really welcome contributions from other vendors and operators. And the second companion draft is actually a very short one, and just explains an additional AVPN extended community to propagate the neighbor advertisement flags. Next slide, please. So why a proxy ARP and the draft for EVPN networks? So the first point is the RFC 7432 EVPN says that the P should perform ARP proxy, but it doesn't give many details about how to do it, or it doesn't explain the nuances of each of the sub-functions that you have in the proxy ARP ND. And besides that, we checked many other documents existing in the IETF explaining things about proxy ARP and ND functions. But first, they are not specific to EVPN networks, and secondly, they do not solve all the requirements that we had. And we were specifically looking at a use case for IXP networks, for Internet Exchange Provider networks. So basically, we put together a draft which is based on an existing implementation and explains how things should work. And there are certain requirements we need to meet. Of course, the ultimate goal is to reduce or even suppress the flooding of ARP and enable discovery messages in the network. But besides that, there are a lot of little things that you need to bear in mind. Things like how do you learn the proxy ARP and the bindings, the IP to MAC bindings, or whether you should flood all the ARP messages or suppress all of them or a mix of them. Also, the solution has to be transparent, and it should not interfere with the regular connectivity between the CEs. Also, we need to maintain the entries, the proxy ARP and the entries, in order to avoid unnecessary control plane overhead, which means that if you have a dynamic entry and it ages out, you need to withdraw the route. And if the owner of that IP is still active, we don't want to do that. And finally, we are also defining, because it's one more requirement, we are defining a mechanism to detect duplicate IPs in the network. Next slide, please. So yeah, there are a bunch of annoying animations, so if you can just go on. Yeah, sorry about that. Yeah, thank you. So the idea is you have an EVPN network. For instance, you have EVI1. It's an EVPN instance. And you have 3 Ps in this example. So the way it works is the concept is very simple, and it's mainly explained in the RFC 7432. So basically, at the access, you listen to gratuitous ARP or ARP messages or info discovery messages. You snoop the information, the MAC to IP binding. You learn it in the proxy ARP table, and you advertise it in EVPN, right? So at the remote piece, for instance, in P3, we can learn the MAC to IP bindings coming from P1 and P2. We put them on the proxy ARP table, and if we receive a local address resolution request, for instance, who has IP1, we can reply directly to the CE. We don't need to flag the ARP request anymore. So as you get to know more and more bindings in the network, you go suppressing or reducing and reducing the amount of ARP flooding that you have in the network. And finally, if all your CEs are normally are known, like in the IXP use case, you can even suppress all the flooding, all the ARP and neighbor discovery flooding, and even the unknown unicast. So next slide. So that was the concept, but there are several things to take into account. So we divide the proxy ARP and ND explanation in 5 sub-functions. The first one is the learning. So the draft explains how you should learn proxy ARP and ND entries. You can learn it from the management plane, that is the static entries, or dynamically from the access, or from EVPN as well, and they have a precedence. The draft also says what you should not learn and what you should learn. There is a reply subfunction, which also says when you have to reply and when you don't have to reply. For instance, if you receive in neighbor discovery neighbor unreachability detection request, because it's unicast, you should not reply to those, for instance. The third subfunction is maintenance. So maintenance is about defining agent timers. Can you please go? Yeah. And then we also define a mechanism to refresh the entries. The subfunction number 4 is actually we say in the draft that we should allow the user, the operator, to decide what to flood and what not to flood. And the final subfunction is this duplicate IP detection, which is actually a protection against 2 use cases. So the first one is if you have a human error and you configure the same IP address in 2 interfaces in 2 different CE routers, you should be able to detect this anomaly. And also if you have a ARP spoofing attacker, and they try to generate gratuitous ARP for an existing IP in order to attract all the traffic, you should be able also to detect that. So what we do is something very similar to what we do in EVPN for MAC duplication, but now for IP, because when you enable proxy ARP or proxy enable discovery, you have also the IP information. So we define a monitor window, and we check, how many moves, IP moves you have. So you learn an IP on one side, and you can also learn the same IP from EVPN. That's in a move. So you monitor the amount of moves that you have in a window, and if you exceed the threshold, you declare the binding in hold down mode. And when you're in hold down, basically you can just trigger an alarm, or optionally you can even inject a gratuitous ARP for that IP with what we call an anti-spoofing MAC address. Anti-spoofing MAC address is basically a managed MAC address known by all the Ps, and you can do things with that MAC address, things like filter the ingress or just log the traffic or things like that. So next slide, please. Yeah, sorry about that again. Yeah, is that complete? Yeah, okay. Yeah, so the other draft is it's very simple. So when you have a proxy-enabled discovery, when you reply to address resolution requests or neighbor solicitations, you need to reply in the P with a proper router flag, right? Especially if you have a network with a mix of routers and hosts, right? The reason why is because you know, a host needs to know if a given IP belongs to a router or a host, so that he can actually update its default router list, right? So obviously, if you do the proxy-enabled discovery with EVPN, you need a way to propagate that information in EVPN. So we are defining an extended community at the moment with only the R bit flag. And basically what we do in this example is in P1 you have a router connected to P1. P2 has a host connected. So at the access we snoop the neighbor advertisement messages, and we learn the MAC to IP binding, but we also learn the R bit. For the case of the router, the R bit will be 1, and for the case of the host, it will be 0. So what we do is in EVPN routes type 2, we send the MAC and IP information along with the R bit flag in an extended community. So in P3, basically we put those entries in the proxy ND table as type EVPN, but we also add the router information because we know that now. So when we reply locally to hosts in P3, let's say that I have a host asking for IPv6 number 1, we can reply saying, hey, MAC1 has IPv6 1, and it's a router. So we send the R bit in the neighbor advertisement. And I think that's pretty much it. So next slide is conclusions and next steps. So as I said at the beginning, it's a work in progress draft, so we really welcome feedback and contributions.
Sorry. We go from Huawei. I have a comment for the first draft. I want to know if PE, local PE, have not learned destination host app information. If the PE receives local CE's app request, what's the PE's behavior? It is drop the app request packet or to flooding the app request packet.
So you normally should flood unknown ARP requests, right? Although in the draft what we are saying is that you should allow the an admin choice to drop the unknown ARP requests if you wanted to. In a case where all your C routers are well known beforehand, and you know all the IPs and the MACs, you shouldn't have any unknown IP. So you should have an admin option to either flag or drop those ARP requests.
Yeah. If the PE decides to flag the unknown ARP request, the ARP request, yeah. How you consider ARP request attack packet?
How do you, can you repeat that?
Security issue.
Security issue?
Yeah, if you receive malicious ARP request package.
Okay.
No,
okay, so
if you're always flooding the request message, it is a huge burden for the whole network.
Yeah, so that's why you have to, you normally, it depends on the use case. So this feature has to be really, you must be able to configure it properly depending on the use case. For this specific use case we are looking at for IXPs, again, you normally know all the IP addresses and MACs, so you normally populate the proxy app tables from the management system, and you should not flood anything. And because you know all the IPs, you you can enable the IP duplicate detection system. You can monitor the IP moves.
Okay, we can discuss in detail further offline.
All right. Thank you.
Eric Nordmark, Arista Networks, and co-author of IETF Neighbor Discovery. So I think it's great that you guys are writing this stuff down, because I think what's currently there in the EVPN specs as do proxy ARP doesn't quite cover what that means, right? So we definitely need to have some more stuff written down. So I would commend you for actually starting writing down these details. One of the things that I'm a bit concerned about is the fact that you need to add these flags, the flags from the NA or whatever, is telling me that, well, what actually happens if the host decide to use some additional options in their NA or NS or NA, right? And we already have some that are not widely deployed for doing security, like secure neighbor discovery. But there could be other ones that get defined tomorrow or the day after. And I sort of wonder whether this proxy approach is the good approach and whether it's necessary. Clearly you want to avoid flooding this stuff to all the NVEs, but you could also use the information that you get with EVPN to say, I know which NVE this host is behind, right? This IP address is behind. Let me send the ARP or the neighbor discovery packet unicast over there. And I will actually get the whole packets traveling end to end. And now these flags, as well as any future options, any security things, whatever, will also travel end to end. You still want the mechanism you have to be able to sort of suppress these things, saying, yes, I know all the MAC addresses and IP addresses in my network, I can just drop these things on the floor, right? But I think thinking about this sort of avoid flooding, but still send them end to end, that might be something to consider. But I still think that we need this type of document to work through what are the details, what do you do with gratuitous ARP, right? What do you do with these other things, you know, the unsolicited NAs, whatever, to make sure that things work the way they're intended.
So thank you very much for the comment. Actually, it's very interesting what you're saying. So I would like to talk a little bit more about it offline.
Yeah, we can talk offline. So.
Thank you.
Robert Raszuk. So this is very useful work, not only for IXPs, but also for data centers. Actually, the proxy ARP is being used today in production for EVPN. My question is, in the duplicate IP detection, how do you handle anycast? There is RFC 7094, which I just found, which discusses the IPv6 handling of anycasting with various technical points, but not for IPv4. So what's your take on that?
Yeah, so the use case we are looking at, they're typically not anycast IPs. So
for data centers, they are on purpose.
Data centers, right? Yeah, they are, yeah. And then obviously, you know, you have more than one host using the same IP, right? So the IP duplicate doesn't make sense, really, in that case, right? So you should be able to turn it off. And the other thing is for anycast IPs, so the neighbor advertisements are sent with the O flag to 0. So what we do in the proxy NG function here, what we are recommending is not to learn those bindings, right? Because they are coming from different places, and that is not good for the proxy NG function. But anyway, because we were focusing on a very specific use case, and we didn't, I mean, we thought about the anycast, and we said, okay, for the time being, it's really out of the solution, but we can think about it, yeah. And thanks for the comment.
We don't hear you.
Okay. Iftikhar, Infinera. Interesting, very interesting work. Just a quick, actually, maybe clarification, or just wondering, is there any impact of, if there's a loop external to in the customer network, how it will manifest in terms of, you know, this IP to MAC learning? I mean, would it have any performance impact? Like, So would it?
But if you have a loop, it should be taken care of by EVPN MAC duplication, right? It's because you will get the same MAC into different PEs.
Okay.
And the EVPN already has an mechanism to take care of it.
Okay, thanks.
Himanshu Shah from Sena. Just wondering if you have looked at the ARP mediation and IPLS IFCs that talk explicitly about the IP to MAC address binding, proxy ARP and all that stuff. Have you looked at it?
I've looked at a bunch of them. What exactly? Which one? The ARP mediation?
Yeah, it was part of L2BP and I think some of the Alcatel-Lucent folks also contributed to that.
Okay.
So you may want to take a look at that. It's all about learning of ARP, proxy ARP, and how do you advertise the IP to MAC binding across the MPLS network using LDP.
Okay.
Okay.
Have you seen any inconsistency with this draft and?
I haven't
or
looked at
something?
this draft.
Okay.
But you said you have looked at other work, so
other works, yeah, that one.
But you didn't look at this.
Not for a long time, yeah. But
okay, so those were part of the L2VPN working group, and those are RFCs. So you may want to take a look at that.
Okay, thanks.
Alex Joseph Cisco. With regard to the Anycast comment and issue, that it can be alleviated if we use IRB and we basically the Anycast address is the Anycast address of the gateways, and that way the ARP response is done locally by each gateway, distributed gateway. So the IRB in here, if you take that into consideration, can take care of it.
Okay. Thanks. Okay, thank you very much.
Thank you. To have an idea, who has read this document? Okay, more commenters than readers, but that's good. Okay, thank you.
Where are the blue sheets and who hasn't signed them? So there's one behind you. Where's the other one?
Where is the second one? Jacob?
Hi, I'm Jacob Heights from Cisco, presenting this on behalf of Satya. This was presented before in the last meeting. What this is about is the designated forwarder election. Next slide, please. Just quickly explaining what's going on. We need to send the bum traffic just using one PE, not all the 4 PEs. And so the one that does that is called a designated forwarder. Next slide. Oh, okay. Next, yeah, this slide. With the method that's described in the RFC, which is using the mod function, when PE1 goes down, all of the what we're seeing here is a set of VLAN tags, Ethernet tags, and the PE that is currently the DF, the designated forwarder for it, in the middle column. On the end column is when PE1 goes down, they all move. So, say for example, we have 893, that's VLAN 893, is PE2 is the designated forwarder. When PE1 goes down, now PE4 becomes the designated forwarder for that one. But PE2 didn't go down, right? So there's no reason why 893 should not continue to be forwarded by PE2 just because PE1 went down. So the problem with that is that the function being used is the mod function of the number of PEs in the set of forwarders, and when that number changes, all of the DFs change for all of the ones that even didn't go down. So the second part of this, using a hash function, you can see that only 894, because 894 is using PE1 for the designated forwarder, so when PE1 goes down, it must get a new designated forwarder, which is PE3. All of the other ones remain on their previous designated forwarder. Next slide. Here I have the example. Here we see right, let's go for the first one, VLAN 891, vmod n equals 3, because n equals 4. So, so the designated forwarder is 192.0.2.4. And then when PE1 goes down, you can see that not only do all the ordinals change, but all of the mods also change, so you can see how the designated forwarder changes for all of them. Go to the next slide. Now, here we calculate a hash for each of the VLANs based on the VLAN and also the IP address of the forwarder. That hash does not change when PE1 goes down. What we do here is we take the largest hash, the IP, the PE that represents the largest hash becomes a designated forwarder. When one of the PEs goes down, the largest hash does not change because the hashes don't change. Right, we can see here for 894, the largest hash is represented by PE1, and when PE1 goes down, it has to change. So the new largest hash is shown in green, and so that guy becomes the designated forwarder. Now, a side effect of this is that you can use this second largest hash as the backup designated forwarder, because when the greatest one goes down, that one actually becomes a designated forwarder, so that can be used as a backup. It also works the other way around. If you start off with 3 and then you add the new one, it's also the idea is least disruption. Next slide. Here we this is the the added part to the draft is the hash function is defined, and that's the hash function there. Actually, I was thinking last night that maybe we should use the CRC of the IP address rather than the VLAN, but that's a minor issue. Okay, that's it. Is the idea clear?
I'm sorry, you said use what instead of VLAN? Your last sentence?
Oh, previous slide, what the hash does is it takes the CRC32 of the VLAN in the XOR function. Now the VLAN tag is a 32-bit, actually Ethernet tag is a 32-bit, right? So it's really not necessary to take the CRC32 of that. However, the IP address could be 4-byte or 16-byte, and that one makes a difference because it's in the vertical column on the previous slide.
So you're saying instead of 32-bit Ether tag, make it, if it is VLAN.
It doesn't actually matter. It doesn't actually matter whether you take the CRC32 of it or not. I mean, if you had a really simple function like, say you just add them up, right?
Yeah.
Instead of doing this thing. What this thing here does is it spreads them out. If you just add them up, then what would happen is that
no, that's fine. I just wanted to make sure we are not using something else instead of the Ether tag. It's still Ether tag is part of the equation.
Oh, yes, yes.
Yeah, that's fine. Thanks.
Yeah.
Who has read the document? Amongst those, who thinks it's a valuable piece of work? Okay, thanks. Same number.
Thank you.
Thank you.
There you go.
Wei Guo from Huawei. This topic is also about EVP in DF election enhancement. This is the handshaking, introduce a handshaking mechanism for DF election. Next. In EVP, DF is used for multi-homing. Only DFP can forward the bump traffic from EVP network side to local access network side. To avoid duplicated bump traffic from network side to local PCE. In current EVP DF election mechanism, it relies on independent reception timer expiration event to trigger independent local DF election algorithm process. And so that will, in some cases, it will cause bump traffic disruption, for some time. In this draft, a use case is provided to eliminate the traffic disruption caused by current EVP DF election. Page 1 and page 2 provides the problem. In this figure, C1 is multi-homed to P1, P2, and P3. But in the initial phase, C1 only provides to P1 and P2. The link between C1 and C3 have not changed up. Yeah. So the EV pin DF election is running between P1 and P2 initially. P2 is elected as DF. P1 is non-DF. Next. And the bomb traffic is through P2. Yeah. Later, after some time, the link between C1 and P3 become up. Yeah. Click. Yeah. Sorry, some mistake. This is P3 describes local ES1, local ESI, not P1 describes local ESI. Yeah, click. P3 advertises ES routes to P2 and P3, P1. Then starts ES routes reception timer. The default value for the reception timer is 3 seconds. Click. Sorry. DF re-election is performed on P1 and P2. Yeah. P3 is new DF, not P1. Is my mistake. Yeah. P2 degrades to non-DF immediately. And next, click. On P3, once the reception timer on the P3 expires, then trigger P3 DF election. P3 is new DF. P3 is new DF, not the P1. Yeah, it's a mistake. Okay. The P2 degrades to non-DF, and the P2 degrades to non-DF, and the P3 upgrades to DF. Is not at the same time. So there are some traffic disruption at the time difference. Next. Yeah. One P3 is elected as DF, and the DF is upgraded to DF. The bomb traffic will forward through P3. Yeah. But before this time, the traffic will be lost. Next. Bomb traffic disruption will be incurred by DF re-election, mostly up to the reception timer. Next. To resolve this issue, a handshaking mechanism for DF election and re-election is introduced. P1, when P1 discovers local ESI and starts reception timer, it's just the same with current DF election mechanism. Then P1 advertises ES routes to P2 and P3. Yeah, P2 and P3. When P2 and P3 receives the ES routes, yeah, it will also advertise local ES routes to P1. It is for ESI discovery, but the ESI discovery message is associated with capability flag. It is to differentiate old PE. It is a new PE. When P1's reception timer expires, it triggers local DF election process. And P1 will advertise its ID route, yeah, to P2 and P3. It indicates I'm DF. The DF extended community with DF election extended the community. The community carries with a DF flag. And when P2 and P3 receives this message, it will block local traffic immediately, then respond with a new message to P1. Yeah, I'm not DF. When P1 receives all neighbors message, yeah, that means P1 receives P2 and P3. Yeah, I'm not DF. P1 will upgrade to DF. It will unblock the traffic. Yeah. In this process, yeah, the traffic disruption timer is equals to the message transmission timer. It is very normal. It is very short. Yeah. Okay, next. The extended community subtype. It may be 03, maybe not correct. Yeah, it is to be defined. In this extended community, 3 flags is needed, is required. C is for DF handshaking capability flag. It is for capability negotiation. DF flag, it is used by the DFPE to notify other non-DFPE I'm DF. You can degrade to non-DF immediately. It is used by the DFPE. Non-DFPE is non-DF flag is used by the non-DFPE to notify the DFPE. Yeah, I'm not a DF. Sequence is used to ensure that the Ps connecting to some ESI are negotiating for some DF election. It is to avoid message disorder. Okay, next. Solicit comments and suggestions.
Excuse me. If you can go to the figure, please. No, yeah, no, the one before that. Number, I think it's slide number 3. That's okay. I mean, this is good. I mean, yeah. Anyway, any one of them should do.
Sequence. Next.
This one?
Yeah, next.
That's one. So, in this figure, can you tell me where we're going to end up with the loop during this process of the DF election? Because in the draft, you talk about we're going to end up with packet duplication and loops. So can you show how we end up with the loops in this figure?
How many times loops?
Loops. Can you show? Yeah, loop.
Lost. Yeah, you mean?
When in the
no loops in this case.
In the draft, you talk about in the existing mechanism in the RFC 7432, because of the DF election, because the timers run independently and so forth, there is a chance, there is a packet duplication and loops for the multicast traffic. So there, I'm wondering where would we end up with the loop? The duplication, I can understand there is going to be a...
DF election is to avoid loop and traffic duplication. Yeah.
Baseline RFC 7432.
Yeah, yeah. EVP DF.
So why in your draft you're talking about the...
I'm not talking...
No, in your draft, if you want me to show you the paragraph in your draft, you mentioned loops and duplication. So if you're not, then that's fine, okay?
It is not to solve loop issue, not to solve traffic duplication issue. It have already
Can we move this to the list, the specific point? Don't hesitate to quote the draft and discuss this to the list.
Yeah, then that's fine. There was a initially for the single active scenario in EVPN baseline, we didn't include the for the all active we had ESI label, which does a split horizon filtering. Single active, that wasn't there, and we had a draft a long time ago, like 3 years ago, written to do this handshaking based on a more comprehensive algorithm, Paxos algorithm, to avoid any transient disruption. And because of two things, we basically we didn't see a demand for that draft. Two things that we did.
But I have not seen the discussion before.
If you go search for EVPN segment route 2011, there is a draft that talks about the handshaking.
The transient traffic disruption is it is a issue. It is an important issue.
I know, but I'm saying that
especially for DCI scenarios.
Right. What I'm saying is, if you that was mentioned, because we are talking only about the bomb traffic that was covered a few years ago in that draft, and because we didn't see the demand, we didn't pursue that. But that had the handshaking, sequence number, and the algorithm was based on the Paxos algorithm. So if you go and just search, it is expired, but if you just search for the EVPN segment route, you will see that.
Okay, Ali, can you please give the draft reference on the list and pursue the discussion there?
Sure.
Thanks. Jorge? Or maybe.
You can give the draft.
Sorry.
Jorge Rabadan, Alcatel Lucent. So we already discussed offline, you and I, and again for the I wanted to share with the working group. So basically, I believe it's a valid work, not for avoiding loops, because EVPN already takes care of it, as Ali was mentioning. To me, it takes care of duplicate packets if you have transit states where you have a dual DF in the network. Okay. As opposed to to rely on a timer, you do this handshaking. But my personal opinion is that it's too complicated, and also it slows down the DF election process, because now you not only rely on a timer, but you also have to wait for this handshake to go on, right, before you really have the traffic being forwarded. And besides that, you already mentioned that, so the extended community subtype type 3 is already allocated by IANA, so you should remove that from the draft, please. And also you mentioned for PVB EVPN, you should use the ES route instead of the AD route.
Yeah, PVB EVPN, there is no AD route.
I agree, but the DF election is per Ethernet segment per ISID. So there's no way you cannot send an indication of DF with the ES route, because it's for all the EVIs, right? So it doesn't work.
Which place doesn't work? But in Georgia, Georgia.
But my comment is, you have an Ethernet segment where you define thousands of EVIs, right? And normally the DF election is actually per EVI. Because you do the service carving or whatever, right? So you end up with a single DF per EVI. But if you send that DF indication with the ES route, is not valid, right? Unless the P is a DF or every single EVI or ISID in the P.
That specific thing, if you want to go that route, that was addressed in the other draft which I'm talking about, EVPN segment route, because the information that we were sending, the information was making sure that everybody has the same information as opposed to the specific pair service instance information. So once everybody made sure that they have the information, then they perform the handshaking to ensure that everybody is on the same page with respect to the information. So if you take a look at it, that draft addresses your concern, should address your concern.
Thank you.
Patrice Brissette from Cisco.
Sorry, just one other comment. Jorge mentioned about the, the duplication and loop. The duplication is naive. I mean, it's not going to cause the network meltdown. The loop is the one that causes network meltdown, and we made sure in EVPN draft there is no loop.
Yeah, sorry. I have a reply to George's comments. Yeah, George's comments. I think handshaking mechanism is very complicated comparing to current EVPN independent timer expiring mechanism. Yeah. I think accuracy, handshaking mechanism is more accurate than current EVPN election mechanism. It must be have some price, yeah, than the simple independent timer mechanism. Yeah, it needs a trade-off. Yeah, if you want to avoid the transient traffic disruption, it must handshaking mechanism must be used. Yeah, independent timer, it always will cause transient traffic disruption, even if it is very short, maybe only 3 seconds. Yeah.
Right. Sorry. A couple of quick comments. That the disruption that you mentioned is for the bomb traffic, not for unicast.
Yeah.
For the bomb traffic, it is when the when you add a new node, not when there is a failure. The failure doesn't cause the disruption, and the failure, the DF election, is very quick.
But the single home, but for the active standby multi-home scenario, it is also cause the unicast traffic disruption. Yeah. This is active access scenario.
For a very short duration, the disruption is on when the new node comes up, as opposed to when the two are already running and one fails. So if I'm wondering, it would be good to get some feedback from the service provider, from the people who are basically have vested interest in the network operation, to say that, specify that, we need to address that, and it worth the overhead, and it and so forth, for the additional handshaking to compensate for the bomb traffic when a node gets activated.
I think service provider doesn't care about the handshaking mechanism.
So Patrice has been waiting for long, and he deserves to make his comment before we move on to the next topic.
All right, I just want to say that I release again what Ali and Jorge suggested, because what you're proposing is very close to what Paxos is doing. And I think why the segment route draft did not get did not fly is because of the complexity of it, as Jorge mentioned. It's super complex to do. So what you're proposing also, I think, miss a couple of things. As what I did not see is how do you handle failure scenario, right? I did not see that at all. You just explained how you do handshaking, but when it's time for failure and recovery, there's nothing about it. So if you think that your idea is very good, I would like to see a lot of details on how you handle failure and recovery, because to me, this is another access. And I think what has been presented prior to your draft, the HRW, is much more better than that.
Okay. I think the select motion is not so much complicated. Yeah. it is a little complicated comparing to current mechanism, and not so complicated.
Okay, thank you. Next topic.
Thanks.
So one comment from the chairs. We've seen popping up some various drafts around the evolution of DF election within the group. We understand they are not all competing, and they address different aspects of it. We want to make sure that these different evolutions are not conflicting, nevertheless, and that there is consistency across the different documents and approaches. So we will possibly take some actions and come to the different authors to make sure that we reach something which is future-proof and consistent across the different visions.
Okay, I'm Kishore Tirvidala. Today I'm going to present this PVVP in Yang model. So these are the others. So I'm going to touch basic overview and all the different components of the PVVPN and the different configuration and the relationship among all the configuration. Finally, we'll talk about the next steps. So the main elements of the PVVPN are there are two components, B component and I component. The B component is responsible for sending the traffic towards the core, and then same thing, receiving the traffic from the core. And the I component is responsible for the traffic coming from the CE facing interface and then forward to the core. And then we have BMAC configuration. There are two types, shared BMAC and dedicated BMAC. Shared BMAC is for the single home, and in case of dedicated BMAC, they will configure dedicated BMAC on the interface. This slide shows all the PVPN components. So it has I component and B component, and the right side there's a customer facing CE facing interfaces. There could be like the interfaces mapped to customer bridge domain, CBD. So where the traffic coming from the interface is mapped to CBD. The CBD is mapped to ISID. Then finally ISID mapped to the B component bridge domain, where the traffic goes towards the core. In the I component, there could be multiple customer bridge domain. And same thing in the B component, you could have multiple B component bridge domains. So there could be multiple I components mapped to one B component. So the Yang model will cover all this configuration for this model. So this is the B component configuration. The B component configuration will have the instance name and route distinguisher. And in case of auto-derived route target, there is auto route target, and the route target for the B component, then the protocol, whether PVPN, control word, whether you want to insert control word. CBP interface is the customer backbone interface, and then there could be multiple B component bridge domains, BBDs. So this is a backbone bridge domain information. It contains the NVLAN ID, which is same as BVLAN ID, and there could be multiple ISIDs. And each ISID can be extended towards the core, or you can use for the local switching in this B component bridge domain. And coming to I component configuration, I component will have the PIP interface, and then it's a corresponding mapping to B component interface, B component instance name, and then there could be multiple CBDs, customer bridge domains. And again, coming to customer bridge domain configuration, we'll have ISID and the corresponding the physical interface associated with the CE facing interface. This is the source BMAC configuration. This is used for in case of a shared BMAC. You could define a BMAC on a service group name. Then you can apply that service group to multiple ISITs so that you can share the same BMAC to multiple ISITs. So this BMAC will have the ISIT and multiple ISITs and associated with the source BMAC. And this is the interface configuration where you can configure the ESI value and then the redundancy mode, whether you like to have single active or all active. And the source BMAC here is a dedicated BMAC, which is used for the multi-homing purposes. So in case of multi-homing, it's better to use dedicated BMAC. So this is dedicated BMAC helps for the multi-homing scenarios. So this is a relationship among all the configuration. The CE facing interface corresponds mapped to the customer bridge domain, and the customer bridge domain mapped to ISIT. Then ISIT will map it inside the I component will map it to B component. B component BDs. B component BDs goes to the B components. This is the different elements and the relationship among all the configuration. Next. So I would like, this is the first draft we published, so I would like to have comments from all of you. And in the first version, we added only the configuration data. In the next, we're planning to add more operational data and RPC and other information. Any question?
Robin from Huawei. This one, in fact, we propose another young model related with the EVPN that in the last meeting. So we have discussed offline about this, the configuration of the EVPN and the PV EVPN has a much similar configuration. Yeah, so that we will try to see how the divide the draft or this can be merged. So I think so this will be helpful to finish the young model work for the EVPN.
Yeah, some of the configuration is common, but in the EVPN you will not have the B component, I component, all those things. So some of there is some differences between the EVPN and PVPN. So probably we can have common stuffs in one place. So whatever, we can talk offline.
Okay, and also in the the EVPN that young draft, we propose another change on the BGP's configuration, because the traditional configuration of the BGP is a little complicated, because in the data center, because the user has much preference for the simplified configuration. So from our point of view, so I think that it's better in the EVPN or the PBV EVPN's young model is better to take into account of the simplified BGP configuration, or else based on the current BGP configuration, configure the BGP, configure BGPR, configure the family. This will maybe take a lot of configuration. Yeah, that's my point.
There are some common BGP configuration which is exists in the B component. So that some of the B component configuration is related to the EVPN. I guess those would be the common. Probably we can talk offline to how to incorporate common data into one place.
Okay. Okay.
Yeah, Himanshu from Siena. I'm going to basically repeat what he was saying. We do have a design team, and I think you are part of that, for L2VP and all aspects of the Yang model definition, BGP based, LDP based, and all that stuff. I think we should take a holistic view, take everything into consideration and see. I mean, maybe this work is a separate in that, but I think we should try to consolidate everything and do a common model. Otherwise, there will be a lot of different push and pull and all that stuff. It will be all fragmented. So to make it coherent, I think we should have a single effort. Yeah?
Okay.
Stefan Litkowski from Orange. I have a very similar comment. We are just starting thinking about the global architecture of the routing, all the routing models, and clearly there is a need for consolidation between all the different services that will be based on BGP control plane. So layer 3 VPN, layer 2 VPN, EVPN. So we will need to be able to use the same bricks. So for example, route targets, some BGP configuration. So this is a global thinking. It's just a global comment.
Yes. So as chairs, we would certainly echo this kind of comments. A proposal for a PBB VPN YANG data model needs to fit very precisely with a YANG data model for EVPN alone. So it's hard to see moving this forward without first having a YANG data model for EVPN.
K. Patel, Cisco. I have 4 comments. First of all, what they echoed is what I have. Okay. Secondly, it'll be interesting to see, or at least you should have a section in your draft where you can explain how your model would fit into the routing model. I can't figure out, and I can't see a good way of, as it stands, I can't see a good way of how it fits under an overall routing model. So that's one. That's the second one. Third one is, it seems that the model seems to be very vendor specific. And one of the things that would be very interesting to see is how do you consolidate and sort of normalize that across the board. And the last comment I have is the way the model has been defined, some of the get configs and some of the delete configs will be very hard to do with a complex XPath. So you probably want to figure out a way to normalize that.
Yeah, sure. I can address those comments.
Basically, as just want to reiterate some of the other comments. I mean, this is a pretty good basis, but it needs to be consolidated with some of the works on the BGP, YANG model, and NetConf and so forth for BGP, and then EVPN and PBB EVPN. But in terms of the capturing the config for PBB EVPN, I think you did a pretty good job in capturing that.
So I'll ask them more. Care, was your first point that it doesn't match any of the BGP YANG models? Because if that's, I don't see how it fits. So please add more detail to tell us how you might attach. Was that your first point?
I wanted to see how it fits in the overall routing model.
Oh yeah, but did you just say, I have no clue how it fits in the
overall routing model,
or even BGP?
Yeah.
So please add detail. Give us something to figure out how it would, we can collaborate. Tell us how you might do the dynamic state that's coming up. Tell us how you might, are you working based on the open config model where you redo dynamic state based on what they presented in NetConf? How are you approaching dynamic? How would you add R2S work on top of it? There's just not a lot of, as Himanshu said, holistic, I love that word, holistic view inside of this. It would provide us with details in order to be able to even understand where you fit. And that would be helpful to add because I'm sure this work will be necessary. Thank you.
Yes.
So this is the third step in the process. I mean, the first step, we need to nail the BGP part of the YANG model. The second step, the EVPN part of it. And then the third step, PBB EVPN. So we need to make sure that, so my question, frankly, is where are we on the, anybody knows the status of the YANG model for BGP? The status of the YANG model for BGP, how far along are we? I mean, you don't need to give a, very long description, just.
The walk is longer than the description, okay? 2 models, hoping to go to 1. Thank you.
Can you write down what you said in the minutes, because we didn't get it at the table.
Don't walk back, no.
Next speaker is Patrice.
Good morning. I'm Patrice Brisset from Cisco. So I'm here this morning to present you the EVPN BPWS Service Edge Gateway. Those are the authors with Ali, Sami, and Danbury from Bell Canada. All right, so what this is about is what the idea is really that we are trying to simplify the operation on the customer, and especially on the service node. So can you just go to the next slide? I think this will be easier. Okay, perfect. So what we have here is it's a network where we have a bunch of access nodes, and they are always connected to those service nodes via the core networks. And the idea is we want to decrease the operational cost on those service nodes. So the concept of the idea is the service node will start advertising layer 2 or layer 3 or EVPN overlay services via EVPN routes to all the access node. So now whenever you connect an access node, the operator can go and can specify that EVC is going to connect to that overlay service, and magically the connection will get established between the access and the service node that has that service that the operator mentioned, basically. Can you go to the next one, please? So here's a bit more details about it, and basically we are using the EVPN BPWS service, and usually on the service config here, right there. Usually you specify your local EVC and where you want to connect. So now what you're going to do is basically you're just going to advertise it to the service node, and the service node will be more like a wildcard. And with the RTs, by using RTs, you can specify to which over the service you want to connect, and then the access node and the service node will simply accept those connections. Can you go to the next slide? So if you take that idea, you can push it even further, and what we are proposing is to use what has been described today, the HRW algorithm, and the draft that was presented by anyway, this is the one from Satya. And basically what we are doing is if you have multiple service nodes which are which present the same services, right? You don't want to go on the service node and say, okay, you're gonna be connected to the access and so on, right? This is the idea. So you need to have an algorithm that everyone's gonna run, and we'll all make, and all the access in the service node will make the same decision. So then only one connection can be picked, right? And if there's a failure, everyone will rerun again the same hash, and you can steer the traffic to the other node. So the real idea here is we really want to avoid operational manipulation on those service nodes. So it's really doing like a hidden functionality basically, and it's kind of a one-side configuration where you only apply configuration on the access node, and the service node will just follow based on that configuration. Next slide. So the benefit, actually there's a typo there, but I think the main one is to reduce not the capex but the opex by removing a lot of configuration operation on those service node. The auto discovery aspect, which is very good, and also the auto provisioning of the head-end functionality on the service node. So those are really the major ones. So yes, I guess the comments and so on.
Okay, Ramadan, Alcatel-Lucent. So yeah, I have two questions. So I think it's a very good idea. The main benefit, if I got it right, is you don't need to configure any attachment circuit on the service nodes, right? It gets automatically attached.
Exactly.
The
Yeah.
VPWS gets attached to a MAC VRF or an IP VRF. I didn't get what the EVPN overlay service means in this context.
You can go to an EVPN core, let's say. That's fine. Ali, you want to jump?
But it's essentially, again, a MAC VRF in the service node, right?
For the EVPN VPWS, you can set up a single EVI, and in that EVI you can set up many point-to-point connections. So the service instance that is referring just that EVI. We just set up one single EVI, and then you can set up all the connections, point-to-point connection through that EVI. And that is already in the EVPN VPWS draft. So this draft leverages what is already defined there and says, okay, this is the only new things in here is basically the concept of the wildcard, because the service node doesn't know ahead of time what is the attachment ID. So it says, I am for this, I am participating in that EVI, and if you guys, want to have a point-to-point connection, then you can pick any of those service nodes.
You can see it origin as, let's say you have an EVPN core or PBVPN core, and in the access it can be an EVPN VPWS as an access.
Okay, thanks. The other comment is that the multi-homing, at least for me, it's extremely confusing in the draft. I guess it requires quite a lot of work, right?
Yeah, we'll refine that. Thanks.
I don't even understand where the ESI is in this thing. So
okay, yeah, we'll clarify that for sure.
I mean, it's an ESI that runs on the service nodes, and you discover it from the
because
AD routes, or
I think what is confusing in the draft is you can have dual home on the access, but you can have a dual home on the service node, and I think that's what we need to clarify.
Exactly. Yeah.
Thank you.
Okay. Thanks.
Iftikhar Infinera. A quick question. So I guess the main benefit I see is that you can use the same EVPN infrastructure to do point-to-point, multi-point services. Because I mean, this particular mechanism, the solution do exist, right? So I mean, you can do today, right?
You can do today. Yeah. No, EVPN VPWS exists. I think what we are proposing here, the extension is more the auto configuration of the service node from the access node. That's really what we are proposing for this. Because see, if you add a new access node on the network, right now what you're going to need is you're going to need to have an operator going on your service node and configure it so the EVPN VPWS connection happens. Whereas with this, you don't need to do it.
Yeah, okay, maybe I can take offline, but I didn't understand the algorithm because I mean...
Oh, for the dual homing? Yeah.
Why do you have to run that algorithm? Because isn't the service provisioning, I can just... I want to go, I can just...
We don't have much time, so please move it to the list.
Quick, to give redundancy.
Exactly.
Thank you for being
Thank
quick. Thanks.
Yeah, while waiting for the slides, so my name is Mohamed Boukader. So I'm presenting this draft on behalf of the authors. So the draft is about an update of an existing RFC, which is RFC 6074. So the problem it tries to solve is that there is some specific items that are specified in that document, which are IPv4 specific only to IPv4, and in order to ensure a functional parity between IPv4 and IPv6, there is some fix that need to be done and updated to existing RFCs. So the beauty is that there is already an analysis document that's recorded and identified which sections need to be updated in RFC 6074. So there are mainly two pieces that are missing, the one which is BGP specific and the other one which is LDP specific. So as you see in the next slide, Soma, please. So there is only one minor update that need to be done for this part, just to change the P address to allow to encode an IPv6 address instead of being encoded in 4 octets as it is in the RFC 6074. And as shown in the next slide, there is also a need to define a new type so that in the LDP, an IPv6 address can be encoded as a source identifier and a target identifier. So there is a new type that is requested there. There are some behaviors that are described in the draft. So the section that is indicated in this slide for this RFC 6074 need to be updated so that to allow both type 1 and type 2 in case there is IPv4 and IPv6 addresses that for DP forwarder. So basically, this is what this draft is about. So it is simple, straightforward, fix an existing problem that is already recorded in an existing RFC, and the only thing is that there is a part that is in the pseudo-wire working group, and the other one which is in this one. So I already made this presentation in the LDP enabled services, and it would be good if you find a home for this draft, which is no controversial. And this ends my speech.
Comments?
Who has read the document? Thank you.
So please encourage comments on the list on this document. Next speaker, Lucy.
Lucy, you have 7 minutes, so I think it's important you give time to discussion, so maybe select your slides.
Okay. Sorry, this is the last. Typically they have a lady first, but today they have a lady last. Anyway. Okay, this draft is describes some inter-AS implementations for data center virtual network interconnect with one virtual VPN network. So regarding this, the option A specified in the 4364, to use in this environment, basically you have this both data center side and the one side configure this the board router as the PE. So basically you have this the virtual interface, sub interface, which is VLAN configured for each logical network, and have this the WAF table to map to individual sub interface. So next one, please. So this one is actually very easy to implement. For option B specified in the 4364, that's required to the board router, both on the one side and the data center side, running this MP BGP to advertise those prefix for each logical network. And with prefix then plus this MPS label. So at the data plan, those MPS labeled package was mapped to those logical network on both sides. Next. So this is a basic concept about this option B. However, there's several ways to implement this at the data center side. So this is this draft to describe about. So for case one, for vanilla option B, basically is saying within the data center side, you are implementing using this BGP protocol. That means on each NVE, they are running as the BGP speaker and running this MP BGP protocol. So exchange the prefix between this as the board router, as shown in this case one. But also possible where more than likely the data center want to run in this case 2, which is they are using this centralized controller, which is the NVA, the elements showing here. In this case, is this controller maintained all the mapping between the prefix and the tunnel and the point. So the controller will push those mapping to the NVEs, which is the virtualization edge. So in this case, really, we don't need using the BGP at the NVE. Instead, we have the BGP speaker at the NVA. So exchange the route between this border router and the NVA. So as shown there. So between the NVA and the NVE, they're possible using some other protocol, as we're seeing there's OpenFlow or those many those different choices to push down. So here, since there's a NVA need to exchange the prefix with the border router, and need way to specify this tunnel endpoint. And we know it's currently in the IDR working group, they are discussing about how use the BGP to support this kind of a binding between the prefix and the tunnel endpoint. So that work is done in the IDR, we believe. But this one, we need that mechanism. So next one, please. Further, we describe, forgot to mention about, for both case 1 and case 2 implementation, actually, this border router, their implementation exactly the same, regardless whether you do the case 1 and the case 2. And also, at the data plane, both and the NVE, their implementation exactly the same. So here we just highlight about what the process need done at the data center border router. In the control plane, basically, the border router allocate a VIN ID per those MPS VPN label when getting the route from one side. And also allocate the MPS label per NVE and the VIN ID when getting the route from NVE. That is control plane behavior. At the data plane, the border router will maintain those outgoing table, which have the entry to mapping from VIN ID to a MPS label, and also have the incoming forwarding table, which maintain those the mapping from those MPS label to those NVE IP address and also VIN ID. And when the package is coming, basically the border router just perform those tunnel stitching between the NVO and one VPN network. So really, there's no payload look at this the border router, and which is mainly provides some scalability. And there's 2 tables showing is one example for those outgoing forwarding table, and one is for the incoming forwarding table. So next one, please.
Can you conclude so that we have time for discussion?
I have one more option need to want to mention. Sorry. 2 minutes. Yeah, I just need it. So we have. Okay. I think in this draft we will also describe the third implementation choice for this option B, which we call the partial option B. In that option is really is the border router have the integration function with the PE function. So that's on the wire, it's the same as identical the option B function. However, this integrated border router have to configure those the forwarding table, the VRF table. Yeah, this is those partial option B. So next, please. So as we're saying, this draft describes a different way to implement this inter-AS options. So then we also provide some comparisons saying those what's the difference. They have some different characteristics. So I don't want to go through. So we'd like to solicit some comment about this implementation, and we also want to request as a working group draft, because we understand the currently working group already adopted some interconnection options, which not using the inter-AS, but we think inter-AS, it is valuable for certain use cases.
Robert Rashuk, one question. So why are you not considering to build IP underlay, which everyone is using and it works well, it scales well, and use option C to connect inter-AS?
Good question. We do have a separate draft. This draft is just to talk about the option B. We have another draft talk about the option C. Yes. So, IP, yeah, it is IP under.
Thank you very much. We're closing.
So don't hesitate to discuss on the list. Don't wait for next meeting. Thank you.
So what draft is it? It's already working. Commenting that. No lookup, no nothing, because it's not right? No, because you are interconnecting your own data center.
I think you have more.
Well, if you don't have your own, then it becomes your option. But you don't need MPLS in underground in any case, because the channel and the word IER you are referring to is actually. And they are doing the mapping. Works perfectly well for multi-data center.
Sorry.
Yes. Well, everything is pluses and minuses. No, I will kill me.
I won't kill you.
No, you won't kill me. Yes. So that's a perfect question, because I got some support from Juniper on that, and honestly speaking, I'm not sure. I will get back to you on that. I have to think about it more a little bit.
Because if you don't, I will kill it.
If you don't, it needs to be killed. Yes, it will actually kill itself, because if I